Murmur is a keyless, non-custodial crypto wallet protocol built on the Ideal network by Ideal Labs. It enables a truly keyless crypto experience requiring no mnemonic, no seed phrase, no secret key, no key store. It's non-custodial, relying on no third parties whatsoever in order to access the wallet. It offers seamless cross-platform interoperability. You can easily use it from a CLI to a browser to a bot and many other various ways. My name is Tony Reamer. I'm a co-founder of Ideal Labs, along with Juan Guirini and Carlos Montoya. We have 3 PBA graduates on the team, as well as Coleman Irby, who's a master's student of physics at the University of Mississippi. The problem, in brief, is that crypto wallets are still really complex to use, really hard to use for the general person. Non-custodial wallets are too complex. For example, MetaMask. Custodial wallets require too much trust, like Coinbase. People have had issues where they've been blocked from their funds because of accounting issues on Coinbase's side. And then there are new types of wallets, MPC wallets, that try to strike a balance between these three. Generally, they tend to find themselves requiring some trust, minimizing complexity for the end user, but they might be a little more expensive. Murmur is a flavor of MPC wallet that implements the Hours of Horus protocol. You can find the link here on the lower left. Hours of Horus is a theoretical scheme proposed 2 or 3 years ago. With the latest work done with Ideal Labs and the Web3 Foundation, we're actually able to fully implement the scheme on top of the Ideal network. The Murmur protocol is incredibly versatile. We will see later on in the demo that it can be used to power a very wide range of applications and solutions, and integrations of crypto wallets into places that you might otherwise find it very difficult to do. Very briefly, a note on verifiable randomness and time lock encryption. The Ideal network is a substrate-based verifiable randomness beacon based on aggregatable BLS signatures. We developed this in conjunction with the Web3 Foundation's Open Grants Program and Decentralized Futures Program. This work should not be considered for judgment as part of the hackathon. This is just work we've already done that we're building on top of as part of our deliverable now. On top of our randomness beacon, we've also enabled time lock encryption. In time lock encryption, a message, as you can see in this diagram, can be encrypted for the future. So this person is at block ID 1. They encrypt a message for ID 4. When that block is finalized, they're able to open the message. So very briefly, I won't spend much time on this. The Murmur protocol works where you specify a static block schedule. You generate future OTP codes. You use time lock encryption to encrypt for future blocks. We then organize that into a Merkle mountain range. And the root of the MMR is used to identify your proxy session. You can think of Murmur wallets as a session-based wallet. We haven't yet implemented the update wallet functionality to extend the session, but that is in our roadmap. In order to use the wallet, instead of verifying a signature, the runtime verifies a Merkle proof and a hash. As you can see prepared here, the hash commits to the OTP code in the call, whereas the Merkle proof verifies that the specific ciphertext of that OTP code is where it should be in the MMR. I will link to the Hours of Horus paper and some further mathematical details in the notes. Very briefly, our architecture looks something like this. Over on the right, we have the Ideal network, which is running pretty much by itself, substrate-based network. On the left, the 4 boxes are the deliverables that we've created as part of this protocol. The Murmur core is the core implementation, or the CLI is a basic wrapper around it. The API is a Rocket Rust-based wrapper that basically just outsources some heavy computation to let us use it very easily in the browser. In the future, we're looking to deprecate this Murmur API piece after making some further optimizations. And here, very briefly, we can see how everything kind of flows together. Here at the bottom left, we have the Ideal network randomness beacon. And you can see here the Murmur CLI has a dependency on the Murmur lib, but no external dependencies on trusted parties. A little differently, dApps, bots, or other types of applications using Murmur.js have to use the Murmur API. The Murmur API is a permissionless API with an unprotected data store. It has protected write access, but open read access, so anyone can read it. The only data stored is what's called a Murmur store, which is just the Merkle mountain range data. This is publicly available data. We don't try to secure it. We don't try to keep it secret. This all data that flows through the API is public data when it gets to the data store. We do have a secret salt that doesn't get exposed. So, to demonstrate the versatility of the Murmur protocol, we've implemented multiple different mechanisms that you can use to access it. As previously discussed, the terminal app, or CLI, is a standalone Rust-based application, blazingly fast, requires no third-party dependencies. The Discord bot, Twitch bot, and Next.js dApp, all three are built with the Murmur.js library. So all three are essentially hitting the Murmur API, as we can kind of see in this diagram. So on the right, we have the CLI with no other dependencies. Murmur dApp and the bots depend on Murmur.js, which calls Murmur API, which ultimately calls the ideal network. So let's get started. What we're going to look at in this demo is a flow of tokens from Twitch to a dApp. The idea is that our Twitch bot enables in-chat wallets to be created per chat. So if I add the bot to my stream, I can let my chat participants interact with that stream to create a wallet, send tokens. So what we're going to do is simulate where a subscriber rewards a streamer, or the other way around. We're going to do this with the foster function. Then we're going to send those tokens to a wallet created within Discord itself using the Discord bot. And then we're going to send those to a third-party application, which uses the Murmur.js library. This is the Murmur dApp on the bottom right. And then finally, we're going to send it to our CLI, which is a fully standalone, non-custodial, locally running application with no dependencies. All right, let's get started.